Good day, this is Hailey Keisha Siligaspi from Tayug National High School, Pangasinan 2, presenting to you my research proposal entitled Arduino-based social distancing alarm on face mask, an ear-saver prototype. Social distancing was implemented to counter the pandemic, but some people ignored this. To address the problem, researchers have developed devices to help people maintain social distancing, such as an ID card system with social distancing alarm, AI-powered cameras, and visual-based social distancing monitoring system. However, these innovations have some drawbacks such as a narrow range and field of view, no immediate reminder for violators of social distancing, and a complicated system. In hopes of addressing these issues, a new innovation is proposed. The device can provide wider range and field of view, has an immediate reminder for violators of social distancing, and has a simple system. How does the device work? After turning on the switch, the device will start scanning the environment. If it detected a human movement within a 1 to 2 meter range, it will notify the user through a sound alarm. But if there is no detected human movement within its range, it will continue to scan its environment as long as the power is on. To build the device, the following will be necessary: 2 passive infrared sensors for detecting human movement, Arduino Nano as the device's processor, a piezo buzzer which will provide the sound alarm, jumper wires for connecting the components, 3 volts lithium coin cell batteries as the power source, coin cell battery holder, and the switch. This is how the device will look externally. 2 passive infrared or PIR sensors will be visible at the front view together with a battery holder and switch. Being an ear-saver prototype, it will have 2 hooks at both ends, while the device will measure 12 cm by 4 cm. Objectives. Generally, the goal of this study is to create a face mask ear-saver prototype with an Arduino-based social distancing alarm, specifically to determine the device's accuracy in detecting people from a specific range in meters, maximum field of view of the ear-saver prototype, and delay time in between detections in seconds. Scientific basis. Based on the objectives given, the following scientific bases are formulated. Using the PIR sensors, human movement can be detected at a range of 1 to 1.5 meters. By adding multiple sensors, a maximum field of view of 240 degrees can be achieved. And the scan response time of the PIR sensors is 1 second, all based on a study conducted by Raghav et al. 2020. The device will be developed in 5 different stages, namely gathering of materials, assembling the device, coding through Arduino platform, testing of accuracy, field of view and delay time, and analysis and interpretation of data. To test the accuracy of the device in detecting human movement, an object will be placed in front of the sensor at different distances. This setup is based on the study of Uliza et al. In 2021. Using the setup, P2, which is the person to be detected, will be walking towards P1, which is the person wearing the device. P2 will be repeating the same action of approaching P1 at various distances. This test will be repeated in the indoor and outdoor setting. Aside from the accuracy, the device's maximum field of view will also be tested. In this test, the researcher will observe if it can detect human movement for up to 240 degrees within a 1 to 2 meter range in indoor and outdoor setting. To execute the test, a person will walk from one reference angle towards another reference angle while keeping a 1 to 2 meter range from the sensor. By doing so, the field of view of the device is tested, starting from narrow field of view to the widest possible range it can detect. The test for the delay time of the device will be conducted by waiting for the device to stop emitting output and then recording the time it took for the device to resume detecting moving objects within 1 to 2 meters using a stopwatch. Again, this is Hailey Keisha Siligaspi. Thank you for listening and God bless.